So today we're going to get into properties of gases. So what we want to be able to learn from this is just how to identify factors that can actually affect the properties of a gas. All right, so when talking about properties of gases, we have to discuss how gases are actually mostly empty space, meaning they're actually really easy to compress because there's a lot of emptiness between the particles themselves. The particles are far apart and constantly in motion. This is part of what we consider to be the kinetic molecular theory, which we will get later on to a different section. Whenever we do talk about gases, we do have to mention the empty space here, and what's termed compressibility, which just measures how much volume can decrease when pressure is applied. Okay, so this is why gases are very easily to like fit in different containers, because of the fact that the particles of a gas can either spread apart or come close together to fit the size of their container. All right. So some factors affecting the gas pressure are the amount of gas, volume, and temperature. All right, so we're gonna kind of get into each one to kind of talk about how pressure is affected by all of these different things. So when we talk about the amount of gas, clearly we are talking about a quantity of gas present in a container. To talk about the amount of gas, we usually measure this in moles, okay? And moles is going to be denoted by the letter N. So we won't actually really get into talking about how moles are involved until we get to ideal gases, but this is how we measure the quantity of a gas in a container. Since pressure is a measurement of the number of collisions as well as just the force over the area, the more particles there are, you can assume that there are going to be clearly more collisions. So if there's more collisions, you're going to have more pressure. So assuming that our temperature and volume are not changing, so they're constant, as the number of moles of gas increases, so does the pressure. And as the moles decrease, so does the pressure. They share what's called a direct relationship. So what one variable does, the other one will do as well. Next up, the volume. This describes the amount of space available for the gas particles to move. We usually use liters in order to talk about the volume of a gas. So as the volume decreases, the particles are more compressed, meaning there's less space for them to move around. So if there's less space for them to move around, that just means there's going to be more frequent collisions, which again, pressure is measured by the amount of collisions. So more collisions means more pressure. So as the volume is increasing, the pressure is going to drop because of the fact that these particles are going to have more space to move around. Conversely, if the volume decreases and the space is tighter, the pressure is going to increase because the number of collisions are going to increase. And this is assuming that the amount of gas and the temperature are not changing. Lastly, we're going to talk about the temperature. Temperature, again, describes the average kinetic energy of the particles of a gas. Okay, so from the majority of whenever we talk about temperature, we're going to measure this in Kelvin. You'll see some centigrade, but mainly whenever we talk about gases, we discuss it in Kelvin. So as the temperature increases, particles are going to gain more energy. And if they're going to gain more energy, that means they're going to move around more. So if they're moving around more, they're going to be moving faster, they're going to be colliding harder, so they're going to get more and more collisions, which again means more and more pressure. So as the temperature increases, so does the pressure, and as the temperature decreases, so does the pressure. So again, these have a direct relationship. So the amount of gas, volume, and temperature are all different ways to affect the pressure of a gas. And in our next sections, we're going to talk about how each one of these relates to the pressure of a gas and just kind of use some actual math behind it.